All right, folks, so now we're looking at our final conversion for this unit, the conversion between moles and particles. Now, one of the first things you need to realize is that the type of particle that you have depends on the type of compound that you have, okay? So if you have an element, then we're going to call it atoms. So for example, if you have calcium, or you have iron, or you have neon, then there will be 6.02 times 10 to the 23rd, Avogadro's number, atoms per mole. Okay, because elements, the smallest unit is an atom. If you have a covalent compound, there will be 6.02 times 10 to the 23rd molecules per mole. So covalent compounds, they start in nonmetals. So you're talking about water or nitrogen dioxide. Those are molecules per mole. If you have an ionic compound, you have 6.02 times 10 to the 23rd formula units per mole. Because, of course, ionic compounds, they're not molecules, they're billions and billions of ions together. Ionic compounds will start with metals, so sodium chloride or calcium bromide or potassium oxide. Those will be formula units. And because formula units can be long to write, I will frequently abbreviate them as FU. Don't read anything into that. All right, so here's what you do. You always start the way that you always start. You read the problem carefully and highlight the thing you were trying to calculate, that is the known. Okay? So for the problem below, how many, excuse me, that is the unknown. Apologies. How many formula units are there in 10.5 moles of iron 2 chloride FeCl2? So, formula units is that. That means that particles is my unknown. All right? So, how many formula units, which I'm now going to abbreviate as FU, of FeCl2 are there? Excuse me. Then find the relevant information in the problem. That's the knowns. So the relevant information here is going to be 10.5 moles of iron 2 chloride. So 10.5 moles of iron 2 chloride. That is the known. So moles, 10.5 iron 2 chloride. Now, if you're dealing with particles, then you will always be using Avogadro's number, 6.02 times 10 to the 23rd particles per mole. So you'll always be using Avogadro's number, which we will, the symbol for Avogadro's number is N sub A, Avogadro's number. 6.02 times 10 to the 23rd formula units per mole FeCl2. Now, we're starting here at moles. We're moving towards particles. So that means that we're going by the high road. Yeah? Multiply by 6.02 times 10 to the 23rd. So 10.5 moles times 6.02 times 10 to the 23rd formula units per mole. Moles cancel, leaves you with formula units, is going to give me 10.5 times 6.02 second EE, 23, 6.321 times 10 to the 24th. Remember, I want two decimal places, so I'm going to look at that number. That's the third decimal place. Is it 5 or greater? No, it's not, so I will not round. So this is going to become 6.32 times 10 to the 24th formula units of iron 2 chloride. And there's my final answer. All right, moving on. Actually, I want to go ahead and highlight that in orange because that's the one that we always have Avogadro's number. Okay, so moving on. How many moles? So this is moles, so there we are. That is going to be my unknown. How many moles of chlorine gas are there in 4.20 times 10 to the 25th molecules of chlorine gas? That's molecules, so that means that is my known. So I just use a capital N when we're talking about number of particles. 4.20 times 10 to the 25th molecules of chlorine gas. Now, the thing that we're always going to have as a known is Avogadro's number. So that's always going to be a known for us. 6.02 times 10 to the 23rd molecules per mole chlorine gas. We're going from particles to moles, so we're going to take the low road, divide by Avogadro's number. So start with particles, 4.20 times 10 to the 25th molecules divided by Avogadro's number, 6.02 times 10 to the 23rd molecules per mole. The molecules cancel. One's on the bottom, one's on the top. So that's going to be 4.2 second EE 25th divided by 6.02 second EE 23. So that is going to be 67.7674. So again, I'm looking at my third place. Is it greater than or equal to 5? Yes, it is. So therefore, that 6 is going to be rounded up to a 7. So I end up with 67.77 moles of chlorine. And normally I will abbreviate moles, so I just take that ES off of there. There we go. 67.77 moles of chlorine gas. And that's it. Now there's going to be 6 for the answer checker. And then on the back, there are 4 places for the Canvas quiz. Please show you're working for everything just like that.